All right, and again, welcome Thursday, noon to 1. This is session number 10, week 10, and we are going to look at section number 12, retirement and savings plans. And this section actually is an important part of your project. So we're going to have a new project, and this is our second and last project of the semester. And it deals with the stuff we did last week and this week mostly, and then throws in some absolute and relative change also. Okay, so the assignments due tomorrow are web work 10 and 11 and the Excel credit cards assignment. And then today we're assigning web work 12, discussion board 5, and quiz 5. Please note that next week we will do our exam review for exam 2. And so the exam is actually open from Monday of next week, so April 1st, all the way till April 13th. I recommend you do it after the review, but that's okay if you don't. If you do it before that and you're prepared, you do well. Make sure you do the review quiz. Okay, spend some time doing that. Be able to get 100% on that. You can answer those questions as many times as you need, I believe. But go ahead and do that. Make sure you do that before you take your exam. And so yes, so April 4th we'll do our in-class review. So we're looking today starting at page 149, and I want to show you that on page 153 we have a table that allows us to figure out some of the items in today's lesson without using Excel, but I'll show you how to do these in Excel also. So please note you need to schedule your exam if you haven't done that. And here we're talking about Celeste and her paychecks in the 401k plan. So the whole idea here is to show you that when you make contributions to your 401k, those contributions are made before taxes are calculated. So we'll see what happens here. So Celeste makes $36,000 a year. That means she makes $3,000 a month, and we just get that by dividing by 12. So $36,000 for the whole year, so $3,000 each month. And then we're looking at her 401k contribution. So in the first example, she's not putting anything in the 401k. In the second example, she is. So she's going to get taxed on $3,000 on the first example and only $2,900 in the second example. Now the taxes are 15% of her pay. So we're going to take, for the first one, 3,000 times 0.15. And that's $450 in taxes. So let's see what happens when we do 2,900 times 0.15. Looks like it's $435. Thanks, Brian. $435. And so the take-home pay is the difference in these two. So 3,000 minus 450 is 2,550. And then the other one, 2,900 minus 435, that looks like 2,465. I want you to look at these two values right here and notice that even though Celeste is putting $100 into her 401k, her paycheck isn't actually $100 less. It's only $85 less. So she's saving $15 in income taxes by investing that $100, and her paycheck would be $85 less if she invested rather than the $100 that she's putting back. So there's some benefits. There are some benefits. Hold on, I'm reading my chat box. All right. So there are some benefits to putting that money aside into that 401k pre-tax. So now you do get taxed on it. It's just you don't get taxed on it now. You get taxed on it when you take it out. And hopefully when you take it out, your tax rate is lower. And so let's continue to look at Celeste here. It says that her HR representative informs her that the company will match 50% of her 401k. So she's going to raise her contribution to 150. So if she's giving 150, and how much is the company going to pitch in? Excellent. So the company's going to pitch in 75. She's pitching in 150, and that would be 225 altogether. So let's see. Her gross pay again is at 3,000. She's gonna put in $150 a month, and so that's gonna take her gross pay minus the contribution down to $2,850. Now she's gonna get taxed on $2,850. We want to do $2,850 times 0.15. And let's see how much that is. Or $2,750. All right. And then we're going to subtract those to get her take-home pay. So $2,422.50 this time. So a little bit less, but not $150 less. So let's see, how much will her take-home be? Okay, we got that. How much will Celeste contribute to the 401k annually? So if she's putting in $150 a month, how much will she contribute for the whole year? Thank you, Nicole. Looks like $1,800. All right, $1,800. And how much will the company contribute? Well, if the company is contributing half of what she contributes, the company's going to contribute $900. And you could have gotten that by just dividing the 1,800 by 2. You could have done it by multiplying the 1,800 by 0.50, or you could have taken 75 times 12, and that would all get you the same result. And so part D says how much total will be invested? Well, 1,800 plus 900, 2,700. And then we want a ratio that compares the company's annual contribution to the total invested. So we're really looking at a ratio of these two. So the ratio is 1/3. And so those of you who put 33 in the chat box, you have to be careful because this is not 33 or 33%. 33% would be 33/100ths, and that is not the same as 1/3. It's close, but it's not the same. So 1/3 is actually, if you put in your calculator, it's 0.3, and that 3 goes on forever. So it's not exactly 33%, it's 0.3 repeating. And please note that that's different than 0.33, okay? So it's exactly 1/3. So we want to write a meaningful sentence to explain this ratio. And so we can say something like 1/3 of Celeste's 401k account was contributed by the company. So there would be our meaningful sentence. Now, if you wanted to write this as a percent, because we can, and we can do that because it's a part to whole ratio, right? Instead of using the 1/3, if you wanted to write it as a percent, you could say 33 1/3% of Celeste's 401k account was contributed by the company. So if you're going to do it as a percent, it's got to be 33 1/3% or 33.33%. And then let's finish this up with Celeste here. It says if Celeste remains with the company for 40 years, she'll have deposits that sum to $108,000. How much was provided by the company? So $108,000 altogether. How much of that would be provided by the company? And we found this ratio up here for a reason, because we want to just take that times 1/3 or divide it by 3. And I think it's going to be 36,000. So remember that, we want to make sure there's no confusion here. So if I contribute $100 and the company contributes $50, that's $150 altogether. So the part that I contribute is 2/3, and the part that company contributes is 1/3. So the part that company contributed is this 1/3 right here, which is $36,000. And we could have also done that by, we could have said 900 to 2,700 is X to 108,000. We could have done it as a proportion also. Or if we did it as using the decimal, look what happens when you multiply 108,000 times 0.33. Do you get 36,000? That's my question. No, you don't. You get 35 something. So if you take 108,000 and you multiply by, I don't know, let's give it 6 3s. See if that gets you 36,000. Does that get us 36,000 with 6 3s there? Not quite. Okay. So that's why we have to use the 1/3 or divide by 3. All right. So let's see what happens here if we make this investment. Now, what happens with the 401k is a lot of times you earn interest on it. Hopefully it's positive and based on the market, or if it's a fixed number, we're going to use a fixed number for our example. So it says, thus far we have only covered employee and employer contributions, but 401k savings plans are also interest-bearing accounts. Celeste's $150 monthly 401k savings are going into an account that earns 2.99% interest annually. We can use Excel to forecast what Celeste's account balance will be for any number of years in the future. And so here's another Excel function. So take a look at that just for a minute. Notice how it's similar to the ones we used last week, the PMT and the PV function. So remember, PMT was you put the value in here that you're borrowing, and that gives you the monthly payment. The PV function, you put in here your monthly payment that you can afford, and it tells you how much mortgage you could borrow on. This dollar amount is your investment amount. Now, it's not just yours, it's yours plus the company. And by putting in this much money every month, and this looks like 2.99% annually, so divided by 12, and this is for 40 years, it will pop out a number and we'll get how much would be in the account after 40 years. So I'll show you that here in Excel. So I'll show you that it does work. Equals FV, so our function, we're going to put 0.0299 divided by 12, that's our monthly interest rate. 12 times 40 years, 12 months times 40 years, and then the negative 225. And we get $207,868.17, just like it shows us right here. Okay. So it says, how much more is in Celeste's account than what she invested? So we would just take that number minus what she invested. How much did she invest? Well, she invested 108,000 minus what the company invested, 36,000. So she invested 72,000. So we're going to subtract 72,000 from that total amount, and that'll tell us how much Celeste. It'll tell us how much more is in the account than what she invested. And thank you, Megan. It looks like 135, 868, and 17 cents. Yeah. So not all of that was earned interest, though. Some of that was what the company put in. So looking at her contribution going up to $200, if we go, let's answer this question first, I guess. If she puts in $200, how much will the company put in? The company will put in 100, so that'll be a total of 300, right? Just as a side note here, $300. So I want to show you how to use the chart on page 153, just so you can do the other problems in the book without having to use Excel. So she's going to have $300 going into her account at 2.99% for 40 years. So on that chart, we want to look up the function that would represent this deposit over the 40 years. And it looks like it's going to be the one on the very bottom left, 0.0299 divided by 12, 12 times 40, and then negative 300. So it looks like she's going to have in her account 277, 157, 56. Now it wants to know how much of this was deposited by Celeste and how much by the company. Well, Celeste deposited $200 times 12 months times 40 years. And the company put in half of that, or 100 times 12 times 40. And it looks like 96 and 48,000. Good. So how much of this was interest? How much did she earn in interest? Can we tell right away? We would just add those up and subtract it from the 277. So over that 40 years, she would have earned $133,000 in interest. More than what she put in. That's a good deal. All right, so let's flip over to page 152 and look at this savings plan. So now the 401k is a savings plan in this case in our book, and so is like the college 529 account in Indiana. And so it says here we can use that FV function to calculate the output on this also. And it's a good thing because Indiana residents could qualify for up to a $1,000 tax credit each year. So here's the example. The Smiths have just had a new baby daughter, Kennedy. They realized the importance of saving for college early, so they opened a 529 account for their daughter. They plan to save $50 each month until she turns 18 in an account earning 4% per year. We're going to use the chart on page 153. So we're looking at 0.04 divided by 12. 12 months for 18 years, and then putting in $50 each month. So find out using your chart. There you go. It looks like Caitlin already has it in there. If you look about midway down the right-hand side of your chart on page 153, putting in those values, so the function would look like this, FV, 0.04 divided by 12. 12 times 18, and then negative 50. That gives us $15,779.62. How much will her parents have deposited into the account? Well, how do we figure that out? How would we figure that part out? How much will her parents have deposited into the account? Well, they put in $50, right? Each month times 12 months times 18 years. And that is 10,000, thanks, Tool. $10,800. So they got about $5,000 in interest over those 18 years, which is okay. So here's what I'm going to do. I'm going to put you in groups to answer the other two questions. Okay. But you guys jammed through this lesson way faster than my other class did, I have to say. So let's see. I'm going to put you into groups, and there'll probably be about four of you in each group. Remember that a tab shows up if you don't automatically go into the tab. Then click on the tab, right? Unblock your pop-ups so you can get there. And then I'm going to have you answer the last two questions. How much interest will the account have earned? And if the parents increase it to $100 a month, how much would they have after 18 years? All right, well, welcome back to the main room. Hopefully you had enough time to get those accomplished. So remember we were looking at the Smith family, and they were contributing $50 a month for 18 years to their daughter Kennedy's 529 college savings account. And let's see, the balance after 18 years of doing that was $15,779 and 62 cents. The parents contributed $10,800. How much interest was earned? How did we figure that out? Yeah, certainly. We just subtract these two values. And what do we come up with? Whoops, 49, 79, and 62 cents. Perfect. I think I saw that in all your chat rooms. Okay, good. And letter E, if her parents decide to put in $100 each month instead of 50, what will be the new balance after 18 years? Well, the Excel function we would put in would be the FV.04 divided by 12, 12 times 18, and then negative 100. So make sure if you're asked to write this on an exam that you don't forget to put the equals sign in, because that's part of it. And it looks like 31, 559, and 24 cents. How much did the family contribute? 100 times 12 times 18. How much is that? 21,600. So if we subtracted that, that would give us the amount of interest that they earned on that account. Looks like 99.59 and 24 cents. All right, so let me ask, are there questions on this content today at this point? Let me rephrase that. What questions do you have on this content at this point? Well, it looks like 3 of you don't have any questions. What about the rest of you guys? Well, how would we get that without Excel? That's a great question, Stephanie. We would have to do this calculation. Remember with the credit card, how we calculate the interest every time? Instead of though finding a minimum payment, what we do is we would just calculate the interest, then calculate the interest again. We'd have to do that every month for those 18 years. So it would be quite a lengthy process. Or there are some calculators that would do this too. I don't think my calculator, I have a pretty nice calculator, I don't think it has the ability to do that. So that's why in your book on page 153 we provided that chart for you so that you didn't have to have Excel to do the questions in the book. Well, you might have a question about this on the exam, but you'll also have a table with possible functions listed. Or it might say, what would you type into Excel? And then you would do that. So we won't be able to use Excel on the exam for sure, but the question could be, what would you type in? And then you'd put that as your answer. Or if it asks for the value, it will give you a table a small table like the one on page 153 or the one on page 155. Okay, and that goes for all the PMT and the PV functions too. So the payments, the future value, and the present value. All right, any other questions on these things before we do our next task? All right, well, you guys do have a project that is assigned. And so let me talk to you a little bit about it. I don't know if I'm going to post a project help video this time. I might, so look for it just in case I do. And you can use the formula sheet on your exam. Thanks for asking, Aaron. It's that yellow page. Now, you won't be able to bring yours with you, but the testing center will have a copy of it, and they will provide that for you. And if they don't, make sure you ask them for it because I did send it. All right, so let's look at this financial project. It says, as an Ivy Tech student, you're making an investment in your education. This project will look at how that investment will pay off if you graduate and get a job in your desired field. So what we're going to do is we're going to compare your future finances with someone who's not a college graduate and assume that the median annual income for a high school graduate is $19,000. And we're going to make some statements using absolute and relative change. So what we've got to do is figure out what your income would be. And so what we're going to do is we're going to take this link, and you probably have to copy and paste it. So I'm going to do that, copy, paste. All right, and then this website shows up with employment statistics. Let me get to the top here. And what we want to do is find whatever occupation you are looking to pursue with your new degree. So can someone give me an example, and I'll show you how we use this table. Like, what do you hope to do when you graduate and you have your final degree? All right, so we have nursing, accounting, social worker, librarian. Okay, great. Now I haven't looked up accounting yet, so I'm going to look that one up. So that would probably be in the business and financial operations. And let's see if we can find accountant. And we just look on the left, accountants and auditors. So we'll just check that one, click on that. And the median income we're looking for. So the median, that would be the 50th percentile. So we're looking at this one. So what you would use for accounting is 69,350. All right. And if we're looking up nursing, let's look up nursing. So that's going to be healthcare. Let's see. So under the healthcare, and it depends on what kind of nurse you want to be. There's lots of different ones. I would highly recommend being a certified registered nurse anesthetist, getting your master's degree in nurse anesthetist. As a nurse anesthetist, it's the highest paid nursing group. So let's see, an RN. So let me see if I can find RN in here. So under healthcare, looking for registered nurse. If you see it, stop me. Oh, right there. Oh yeah, see, nurse anesthetist. Look at the difference if you look at those way out. So registered nurse, annual mean wage, we don't want that, we want the median, but look at the average, 62. Nurse anesthetist, 161. See the difference? That master's degree. All right, so let's click on RN, registered nurse, and we want the median, remember, the median, $70,000. That's gone up quite substantially over the past couple of years. What we'll do is we'll put these things into Excel. So I've provided you with an Excel spreadsheet that I need you to turn in. And what you'll do is you'll put the high school salary in here, 19,000, and then you'd put yours in. So let's do the nurse, 70,000. And then you want to do your other calculations. All should be done with formulas, okay? So for example, the monthly salary, we would do equals, and then click on that guy and divide by 12. There's the monthly salary. And then over here, equals, actually we can just probably slide it over, whoops, and there it is. And then use formulas to find the absolute and relative change over here. 1/5 of monthly salary, how do you think we'll do that? Start off with an equal sign, right? And then take that thing divided by 5. Okay? And then you'll have to look up an APR. So if I continue along this project, the first thing you're going to do is an income comparison. Make sure you're reading what you need to do, okay? Then we're going to do a housing comparison. When you do the housing comparison, what you'll have to do is you'll have to look up an APR for mortgages, okay? And you'll have to cite where you got that. So see how it says down here, cite the sources you used. Research housing costs in your area or the area you'd like to live and discuss whether or not your future salary will allow you to buy that house. Okay, or what kind of house, what you could afford. If you want to include pictures, whatever in your project, do it. This is your last project of the semester. You can use it in your education portfolio, so do a nice job on it. So where do you put that APR? You're just going to put it in this box right here. So let's say it's 4.5%, or let's say 5%. And then the home value, you're going to have to do based on that 1/5 of their monthly salary. So the home value, that's where you're going to use that equals PV, right? Because the payment is going to be this amount up here, that 316 for this case. So follow the directions. It's very straightforward. And then you're going to do a retirement comparison. So you're going to do the FV function, and it says you're going to earn a 5.75% annual rate of return, and 9% of your gross monthly income is going to be set aside. So, when you're putting that in, you're going to find your contribution. So you do something like equals 0.09 times your monthly salary, right? And then it looks like on my Excel sheet I have an extra line. I guess we don't need this one. But we want the contribution. I don't even think we need that either. We probably need the balance though. So, you're going to use your FV function here. FV, FV, and then put in your numbers from your project. And then when you do it, I'm just going to make up numbers here, okay? 0.02 divided by 12, comma, 12 times 40, comma, and then don't forget we're going to do negative of that value. And use the formula, okay? Don't type the number in, because we want to be able to look at this and say, okay, what if I change my salary? What if my salary is 80,000? If I get raises for a few years, how does that affect things? All right, and then the other question here is, still assuming the 5.75% return on your 401k, what adjustments would you have to make to your investment to reach a balance of $1 million at retirement? You do not have to consider this for the high school graduate. And then an explanation. So one of my students in my other class asked, do we use the years we have left in that calculation, like here? Whoops, not that one. In this calculation, use the 40. So if you're already 45 years old, you might not work 40 more years, but just put the 40 in there, okay? And then maybe you can do another calculation that says, well, maybe this should, now I have this all screwed up. Maybe you can do another calculation that shows, well, I'm only 18 years old and I want to work for 50 years. Maybe you want to work till you're 68. And then maybe do the FV function for that and see how that, affects things. Okay, so just some ideas. Be a little creative with your project and make sure you've answered everything though. And then here's all of these items. Okay. And then there's also a rubric. Brian, I wish I was retired already. I looked into retirement. It looks really, really good. So in your project, let's see if I can get that here for you. So in the project, I put in a rubric. And so you can see exactly how this thing will be graded. Okay. I don't know, this should say 1/5, I think, based on your project, right? Let me look real quick. Or whatever it says in the project, that's what we're going to use. So the housing, 1/4, yes. I think my Excel sheet is not correct. In my Excel sheet, it says 1/5, but it should be 1/4. Oh my goodness. Now I can close that out probably. All right, so there's the rubric. And make sure that you follow it. Make sure that you know, when you write your paper, make sure that you have your organization. You have an introduction, the main body, the conclusion. Okay. And this is due on April. It's due no later than April 13th. Yes. Okay. So the rubric is included on the in the canvas right there. The project, the Excel spreadsheet. You'll have to make some adjustments. Okay, because it's not exactly correct, it appears. Let me look and see, actually. So in the Excel spreadsheet, I guess what I can do is make the change. Oh yeah, it says 1/4 on here, on yours. And then we'll probably have to block out these spaces right there. Okay.